to go over how to do some of the graphing questions in section 2.5's homework. I have that the graph of y equals f of x is shown in blue. We need to draw the graph of y equals f of 1/3 x shown in red by determining how much of a stretch or compression, which I also call shrink in the notes, will transform the location of the indicated blue points. Drag the movable red points to the desired coordinates. So what I want to do is I have my blue graph here. Each of these red points that I have here is going to correspond to these blue highlighted points here. And I need to drag each of these new red points to the new points for the blue graph. So going back up here, we have that we have f of 1/3 x. So first of all, our 1/3 is inside our parentheses, inside of our parent function, even though we don't know what the parent function actually is. I just know it's inside the parent function. And that value is between 0 and 1. So I'm actually going to be doing a horizontal stretch. And I'm going to be stretching by the reciprocal of 1/3, which is 3. So all of these blue points that I have on here for my original graph here in blue, all of these y coordinates, I'm going to be multiplying by 3. But their y coordinates are staying exactly the same because I'm only dealing with the horizontal transformation. So the first point here is 0, 0. The x coordinate is 0. Multiplying x times my x coordinate of 0 times 3 still leaves me at the origin. My next blue point has the x coordinate of 1. I have to multiply that x by 3. So 1 times 3 gets me 3, and I still keep the y coordinate of 2. My next x coordinate is right here where my mouse is. The x is 2. 2 times 3 gets me 6. I still need to keep the y coordinate of 1. The next point that I have is here at the end of my mouse. That has an x coordinate of 3. 3 times 3 gets me 9. I still need to keep the y coordinate of 5. So I'm going to go 9 up to 5. The next point I have is here at 4 at the end of my mouse. I need to take 4 times 3 to get me 12. And so 12, and I still keep the y coordinate of 1. I missed a point. This one, was it this one? This one, was it this one? Which point did I miss? 2 times 3 gives me the 6. 3 times 3 got me the 9. Oh. It would actually help if I went to the correct point for that previous one. So wait a minute. I said 3 times 3 was 9, and I needed to keep that at 5. There we go. Okay, sorry, I messed that one up. I think I slid it wrong. Okay, so back here to this one. 4 times 3 is 12, and I keep that at 1. And then my last one, I have an x coordinate of 5. 5 times 3 gets me 15, and I keep that down there for the y coordinate. So let's see if I'm right. Yep. So all I'm doing is taking the x coordinates of all those blue points and multiplying them by 3 for my transformation, and then we should be good. For my next question, I'm looking at the graph of y, which is equal to f of x, shown as a red dashed curve. We need to drag the green movable points to draw the graph of y equals negative f of x. Notice that you can control the positioning of the reflective function with the coordinate labeled drag function, and control the width of the reflection with the coordinate labeled control width. So as you can see here, you can't really tell like where in the world is the red dash curve, but if you move it off of there, it's right underneath. So before I go messing with the graph, I have that negative out in front. So that means I am reflecting about my y-axis. So this means I'm reflecting about my x-axis. So I need to take all of my y-coordinates on my red function and multiply them by -1. So looking at the point here at the end of my mouse, I see that my y-coordinate is +1. So +1 times -1 would get me down here to -1 where my mouse is now. So I'm going to take this and place that point that was originally right up here with the end of my mouse is now going down here. And then if I look at, I need to kind of flip this. So, oops, we need to control how wide it is. So I'm going to go back, okay, let's see, to our dashed point. Let's see. So right, oh crap. Let's see if I hope I can get on right where I wanted it to be. Okay. Okay, so there's another good point on my red one. So on my red one, there is, oh shoot, there we go. My y-coordinate was -3. -3 times -1 will get me a +3. So I keep my x-coordinate the same as -2, but my y-coordinate goes to +3, which is, I think, not where I'm at quite. So this would be 1, 2, 3. I need to be up one more. There we go. So that should be my reflection. Let's see if I'm right. Yep. Awesome. One more graph here. So we're given the graph of y equals f of x as shown in the red dash curve. We're going to drag the movable blue point to obtain the graph of y equals f of x minus 3 minus 5. So I'm going to start off by looking at, here I do have the origin as one of the points on my red graph, and I'm going to use that as one of my parent function points. I see I have that x minus 3 inside the parentheses, so that really means I am moving my origin right 3, so 1, 2, 3, so where my mouse is. And then I have -5 outside of that, which means I have a vertical shift down 5. So from where my mouse is, I'm going to shift down 5. 1, 2, 3, 4, 5. So I should be right there where my mouse is for that point. So I'm going to take my blue point and drag it over to here, which I think was right there. Let me double check my counting. 1, 2, 3, 1, 2, 3, 4, 5. All right, and that should be your new graph. I strongly suggest you just don't do it out in your head like that. I would take like that, the origin that you had right here, and actually write it down and write down the transformations that you're going to be applying to it. If you have any questions with any of these graphs, please let me know.